So welcome to the video going over question 15 on the quiz. So this was one of the questions that I think people struggled with the most. So this is one probably most people will be watching. So here we have a reaction or a combustion reaction that's occurring. And that combustion reaction, I'm sort of going through what this text says. That combustion reaction is occurring here. And the heat released by the combustion reaction is heating up the water. And what they want you to first do is calculate the delta H for the reaction as written. And to do that, you first have to calculate the heat gained by the water. Now, the reaction is occurring underneath the water and not in the water, so we do not have to include the mass of the alcohol that's burning here, the propanol, in our calculation of the heat gained by the water because it's in the beaker. If the reaction was occurring in the beaker, then you would need to include the mass of this. And you'll see that is what is happening, I believe, in question 17. The reaction is occurring in the cup. So here we don't have to include the mass. So again, we've done this calculation a million times. So the mass of water is 125 grams. Again, I can't say numbers. Hopefully by now you know the specific heat of water is 4.18. And the change in temperature, we have to subtract these two temperatures. I believe if we do this is 29.1. Then we get out our handy dandy calculator and the AP button press. And we get 15,200 joules. And then whenever you're calculating delta H, we have to convert it to kilojoules, so that's moving the decimal place 3 places or dividing by 1,000. So it's 15.2 kilojoules are gained by the water. Whenever you're calculating enthalpy from a reaction or from a experimental, it is always the negative of the Q divided by the moles of the limiting reactant. So here, whenever you have a combustion reaction, the limiting reactant is always the alcohol, because oxygen is just prevalent in the air. So we have to find the moles of the alcohol that they reacted here, which was this lovely guy here. So they tell us the grams right here, so we can divide by the molar mass. Hopefully you can calculate the molar mass correctly. So we have 55 grams of the alcohol, and again, I'm getting that from here. And if I calculate the molar mass of this, and we've done that a million times, so hopefully you're not having problems with that, that is 60.067. And when you button press this answer, or when you get somewhere around 0.009156. So now we have the moles, and we have the heat. So we put in the negative of the heat, because again, the heat was released. So that means the reaction is exothermic, and delta H needs to be negative. So delta H divided by the moles, which was 0.009156. And again, this is the moles not of the water, but of the thing that's reacting underneath the beaker. You calculate the heat of the water, okay, and divide it by the moles of the limiting reactant of the reaction. And when I did this, I got negative 1,660 kilojoules per mole. And I believe the sig figs were 2, so it would be negative 1,700 kilojoules per mole. There. So again, this sort of equation, whenever you're getting delta H from a reaction, this equation here is important. So it is determined that the magnitude of the delta H calculated in this experiment is too low. Explain a possible reason for this. Include equations to explain your reasoning. So for B, the answer that I was looking for, although others were accepted, is generally when you're doing these experiments, heat is lost to the air. So how does that affect the equations? Well, if we started off with this, right? So Q equals MC delta T. Right? If heat is lost to the air, the change in temperature will be too low, which will make Q be too low. Again, because some of the heat is not going into the water, so it's not heating it up. Instead, it's being lost to the air. So now, if Q is too low, and in the reaction you divide by N, okay, then delta H will be too low, but it's important to say too low in magnitude, because it's actually more negative, which means it's so, it's actually less negative, which means it's actually higher, it's a higher number, so too low in magnitude, or you could say less negative. Now again, the reason why the change in temperature occurs is because some of the heat, instead of going to heat the water, goes to heat the air. So the change in temperature is not as good as it should be. Therefore, the heat is too low, and if the heat is too low, the magnitude of delta H will be too low, or it will be less negative. So there was a similar question like question 15, so this will help with question 15.